All right, Ethan M., I cannot see you. Hopefully you will come back at some point.
Exponents.
You can use exponents if you like.
Oh, okay, that's cool.
Okay, thank you. Ethan, are you working this problem?
Yeah.
Ethan M.?
Yeah.
And Brandon, you're working it, right?
Yeah.
Okay, excellent.
Can you repeat numbers? No, right?
Well, can you ask that question one more time?
Can you repeat numbers?
When you say that, for instance, like if you already used a 7, you can't use it again.
Okay.
Does that's a really great question, Alex, because that's a clarification question. Really important. And guys, do not do this in your head. Please write it down. Andreas, I see your hand holding up your head. I want to see you writing. Because trust me, you'll find it much easier. I'm just going to give you a little push right now. You ready for the push?
Yes.
8 times 3, that's what you're ultimately going to get.
Oh, wait.
I don't look at the numbers until I
Mr. Kramer, I know.
Hold on. Good. Just raise your hand electronically there. So we're going to start with Alex and then Ethan M. and then Andreas and then Will. Go for it, Alex. Go.
So you start with 9 minus 1 is 8, and then you subtract 4 from 7, which gives you 3. Then you multiply the 2 together, the 2 differences.
Absolutely brilliant. That is so sweet. That's a great solution. Did anybody find anything different than that? Ethan M.? Wow. So you all found the same solution? By the way,
I got a good one.
Oh, go for it, Ethan.
9's factorial. Wait, 9's factorial.
Wait, 9 factorial?
Yeah. Minus 7's factorial. Then 4 minus 1. Then take that factorial and add it to 9 minus 7's factorial.
No, I see like 9 factorial minus 7 factorial 72. Divide that by 3 is 24.
So
wait, I meant like factorial as in you don't multiply them, you like add them. Is there a way to do that?
Yeah, but you, Ethan, when you did this, did you divide by 3 factorial?
No, I meant like I did one thing wrong. I was like calculating it as like adding them, not multiplying them. Is there like a function for like
No, there really isn't. But Andreas, talk to me.
Yeah, 9 factorial minus 7 factorial. If you write all the numbers out, you cancel them.
How many people?
No, 9 factorial divided by 7.
How many kids there?
Now listen to this, guys.
Yeah.
Now listen to this. We're going to start over again. 9 factorial divided by 7 factorial. By the way, I hear someone speaking. I'm not sure. Oh, I think it's, I know. So 9 factorial divided by 7 factorial. We're going to talk about that right now. I'm going to clear this screen because Ethan, you're talking about subtracting factorials. But that's not going to get you there. But I think with a little help, we're going to get there together. Are you guys ready? What is 9 factorial? Who can give me 9 factorial? What's the idea of 9 factorial? Brandon, do you know factorial yet? So 9 factorial. And I'm looking, I don't see Will now. Okay, Ben, are you familiar with factorial? Is that a yes or a no? Because I can't hear you. You are. Okay, so 9 factorial, guys. Go ahead, Andreas.
Is 9 times 8 times 7 times 6 times, yeah, all the way to 1. And then
guys,
factorial's the same thing, but
hold on 1 second though, Andreas. Do I have to write out times 1, guys? Kathy, do I have to write out?
No, you don't have to write out times 1.
No, I do not. And Alex, I'm going to unmute you again because you were talking before, so I muted you. So 9 factorial divided by 7 factorial. Look what happens,
Is
guys.
equal to
Wait, before you say what it's equal to, for those of us who do not yet know, 9 factorial divided by 7 factorial. Do you guys notice that the 7s cancel? Who can articulate why the 7s cancel? Who can articulate why? Ethan M?
it's because like if you multiply a number by 7 and divide it back by 7, it's gonna be the same number.
That is one way to describe it. Alex, can you describe it differently?
It like occurs in both sets basically. So
A little more clearly, it didn't come through.
it occurs in both sets. So if you have it in both sets, I assume it's basically the same. Well, I'm not sure.
Okay.
Wait, never mind. Actually, 7 times divided by 7 is 1.
Yes. Guys,
Okay.
look at this. A divided by A is 1. Whenever you have 7 divided by 7, it's 1. 6 divided by 6 is 1. 5 divided by 5 is 1. And when you multiply 1 times anything, it is that number that you multiplied it. So guys, what are we left with here? Go.
9
Come on,
times 8.
9 times 8. What are we left with?
72.
Say it out loud, please.
72.
72.
And then you divide that by 3 to get 4 minus 1 to get 24.
And do you see the 4 minus 1, guys? 4 minus 1 is our 3.
Oh, so my way technically works.
It does work, but not 9 factorial minus 7 factorial. So the way you just did that, Ethan, and with everybody's help, really, really cool. Really, really cool stuff. Now I want to show you something that's a 3 dot. 3 dotters are much more difficult. 3 dotters are much more difficult. And here is a 3 dot. Are you guys ready?
Yeah.
2, 3, 2, and 5. Your target is still 24. Everybody pick up those pencils and
I
start
have one.
tearing it up. Okay,
I have
send it to
one.
me in a chat so everybody else can think. And Ethan,
Actually,
you already have one. Ethan,
Never mind.
G?
Never mind.
Oh,
Okay.
never mind. Okay, we'll come back to you. Ethan G, do you have one too?
Yeah.
Okay, don't give it yet. Try to find another one. Try to find another one, please.
Oh, wait a here. Mr. Kramer, can I send mine to you?
Oh yeah. Oh, all the chats come to me directly.
Can I send mine to you?
Please. You never have to ask to send me a chat. You never have to ask. And whoever wants to share, remember, it's not a contest. It's just a matter of us trying to
I got it.
support each other. Who's the I? Since you didn't, you have to hit your raise hand, please. And raise hand electronically there, Alex, just so I know you can
I'm
do that.
trying.
Yeah. Andreas, whoa. 5 times 4, 20. That's sweet. That's really sweet, Andreas. That was nice. I'm going to show everybody that in a minute. We're going to tell them.
Oh, Mr. Kramer, I came up with another one.
Awesome. Send it over. Alex,
Here it is.
give me yours, please. Go.
5 squared, which is 25, minus 3 is 22, plus 2 is 24.
So 5 squared
Minus 3 plus 2.
minus 3 plus 2. Let's see if that works. So give me the 5 squared is.
5 squared is 25. Minus 3 is 22. Plus 2 is 24.
That is absolutely fantastic. That's not even a little bit fantastic. I love it. Now, I want to have Andreas take us through his factorial one.
Okay, it's
How do I
5
do that?
factorial divided by 3 factorial.
Wait, you'll have to say it slower
Okay,
now.
5 factorial divided by 3 factorial.
So 5 factorial divided by 3 factorial. Who can tell me what that number is besides Andreas?
Oh.
Remember what we did last time? We did the 5, the 4, the 3, the 2, divided by the 3 to the 2. And guys, everybody say it on 3. 1, 2, 3, go.
20.
20.
And that's 20.
We
Now,
have-
Andreas just used the 5 and the 3. And of course, now what is he going to do with his 2 and 2?
Add
Multiply them or add them.
He's going to add them. That was beautiful. Now, did anybody see 2 to the 3rd power?
Yeah.
And 2 to the 3rd power times 5 minus 2. Isn't that 8 times 3, guys?
Oh, okay.
Yeah.
So that's kind of a sweet one. Brandon, do you have one for me? So I lost your video there. I lost your sound. Ben, do you have anything yet? Want to share yet? Will?
Not really.
Okay, no problem, no problem. Now, these can be very difficult. Kathy, you have one too? Try to keep yourself unmuted if you can, because then it's easier for me when I want to hear you guys, and also try to keep that. All right, now guys, I want to talk about one of the concepts that I was thinking of is this. By the way, there's a lot of feedback from somebody. Somebody's like shuffling paper, moving stuff around. Alex, you have a question. Go.
I have another solution to the last one.
Oh, dude, you got to give it to me.
2 to the 5th, which is 32.
So 2 to the 5th.
Wait, 2 to the 5th is 32.
Beautiful.
Minus 2 to the 3rd, which is 8.
Oh, wow.
Wow. Whoa. Guys, what about that? That is elegant. That is elegant. I love it. I love it. Now, guys, this is exciting. This is very exciting. Now, I want to ask you a question. How many possible cards are there? How many possible cards are there? And by the way, there's somebody who's making noise in the background. I think it's a parent. Oh, it's Ethan M. Okay, so I just.
Mr. Kramer,
Yes.
what are the possible numbers in the cards?
All right. So you're only allowed 1 through 9, the digits 1 through 9, and there are always 4 cards. There are always 4 cards. Now, I want us to do this as a team. I want us to work together to figure out how many possible cards are there in this game. Now, for instance, you guys know that the card 1111, is that a possible solution?
No.
Could you ever do anything to get a solution there, guys?
No.
No. So I am not talking about possible solutions. I'm talking about possible cards. Now, when I first posed this question to myself, would you guys like to see a big mistake that I made?
Mm-hmm.
You guys want to see a huge mistake? So here's what I did. I said that there are 4 cards, and I said that the cards must be, well, there's only 9 choices, 9, 9, and 9. And guess what?
I thought there were 9 cards.
Using the fundamental counting principle, what would I do? Come on, 9 what? Times.
Times 9
9
times 9.
times 9 times 9. So if I do that, guys, which is 9 to the 4th power, or 81 to the 2nd power. By the way, do you guys all see why this is 81 times 81? Do you guys see that?
Mhm.
Do you see 9 times 9 times 9 times 9? And if I do a back of the envelope on that one, I believe I get 6,581. And guess what? I was way, way off. And the reason why your friend, Mr. Kramer, made a big, big mistake,
Oh,
and I'm going to show it to you. Well, who can explain why this is a big mistake?
Is it? Oh, sorry.
Wait, hold on a second. Who knows why this is a huge mistake? Ethan M., we're going to start with you, and then we're going to go to Alex and whoever else. Go, Ethan.
Maybe because you're counting all of the possible. Oh. Maybe it's because you're counting all the possibilities, including the ones like 1 times 1 times 1 times 1.
No, because I included those. Even the ones that are impossible, Ethan, I am including here. But still, my number was way, way off. And why is that? And I'm going to start Andreas and then back to Alex. Go.
Because don't you have to use like the permutation or combination formula for it?
You do.
Yeah, but I don't know the exact because you didn't count all the solutions.
Hey guys, check this out. Do you see those four numbers on that card? You see that?
Yeah.
2763. Well, guess what? 3726.
you have to multiply by 2.
Oh.
Isn't that the same thing?
Yeah.
Yeah, you have to multiply it. Yeah, it's not all the solutions that were.
So guys, here's what happened. When I went back to the drawing board, I just wanted you to know that I make mistakes all the time, and this is one of those situations. So what I did was I wrote out the numbers, digits I should say, that are possible. And then I said, you know, I created these things I call partitions or separators. And I thought to myself, I have to choose 4 cards. So the 4 cards that I said I would choose, so the 4 cards, I called those X. So each one is an X. So I could do like X, 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 and X. And what card would that represent?
1, 1,
1, 1, 1, 1. Now, that's one of them. What if I did X
represent other things?
X, X, X? No. In this case, I am saying that X represents one of my digits. So, Will, can you tell me what card this represents?
2, 4, 4, 7.
Awesome. So do you see how this is going to work? And Alex, what were you going to say there?
What I was thinking maybe where you went wrong is you're implying that it goes 1, all the ones, then 1, 1, 1, 2, 1, 1, 1, 3. But you're not counting for all of them. So the answer could be that times 4 or 81 to the 4th power.
Ooh, you're going the wrong direction.
Wait,
So
it's
my
low.
number of 6,500 and change was way too high.
But we're not counting it. Are we not counting it? We're not counting them if you just rotate the numbers, right?
That's right. Now, guys, let me ask you a question. What card, Ben, does that represent? So, Ben, what card does that represent? So this X is for the 2, Ben. This X represents a 3. This X represents a 5. That X represents a 6. I'll give you another one here. And so, Ben, what does this represent? What card?
Oh, wait.
Ben, there are 2 4s here, Ben. Do you see it?
Wait.
And
Yeah.
there's 1 5, and there's 1 6. So
That
this
card
card,
19?
so say it again, Ben. This is 4 4 5 6. Ben, do you
What?
see that?
There's 24 cards. Is there 24? No.
Yeah.
No, there's way more than 24. Way more
Good.
than
Okay,
24.
good.
Brandon, what does this represent?
Which one?
It's the one that's on the screen. The X's that I put in there. What does that represent?
The cards.
Which card does that represent?
It represents 6 and 7.
No, 6 and 3 sevens.
7.
Because I put an X 3 times under the 7. So do you guys understand now what the X's represent?
Yes.
Yeah.
Okay, good, good. Now, guess what, guys? If there are 4 X's, and I'll just randomly put them in here, how many different ways? Let's count them together. You ready? Each partition, how many partitions are there?
8.
Say it out loud, please.
8.
So there are 8 partitions, and there are 4 X's,
32.
and therefore 8 plus 4 is how many different items are we moving around here?
32.
No, 8 plus 4, guys.
Oh, I thought
12?
Plus 12.
That looks like
So
multiplication to me.
And for those of you who don't know,
That's fine.
the
Oh, 4x8.
the notation
4x.
NCR means N items taken are at a time. So NCR means N items taken are at a time. So how many items do we have here, guys?
12.
12 items taken
4.
4 at a time. And for those of you who are learning this for the first time, NCR is N factorial divided by N minus R factorial times R factorial. Now it looks very complicated, but it's not. 12C4. Come on, guys, give it to me as a factorial. Go. Come on. Go ahead. N. N is 12. N is 12. Come on, guys. 12
times 11.
factorial divided by, now what's N minus R?
8.
8 factorial times, come on, guys.
4 factorial.
4
There you
factorial.
go. And so our answer, guys, to 12C4 is 12 factorial over 8 factorial, 4 factorial. And are you guys watching this? Do you remember what we did with 12, 11, 10, 9,
Oh, it's
and then 8? Isn't this 8 factorial? Don't 8 factorials cancel, guys?
Yeah.
Do you see that? But
Yeah.
what does not cancel?
The 4.
The 4 what?
And a 4 and 12
It's called 4 factorial.
factorial.
The 4 factorial did not cancel.
But
Now-
the 4 and 3 cancel with the 12.
So everybody watch this.
And the
4
2
times
cancels with
3
the
is-
10.
Ben, 4 times 3 is?
Oh, 12.
Oh,
Ben, thank you. And so 12 divided by 12 cancels.
And
What
10
about the
divided by 2 is
2?
5.
And the 10
Well,
is 5. Who can tell me what is 99 times 5? Don't say it out loud. 99 times 5. Come on, guys. Everybody should be doing this. You have 99 times 5, which is, by the way, 5 times 100 minus 1 in parentheses, which is 500 minus what, guys?
5.
Which is what?
495.
So there are exactly 495 cards. Now, I was really, really curious. And I said, hey, how many of those cards are impossible?
Wait. I have a
Yes,
question.
Alex, go for it.
Why did you cross out the 12 and the 10?
I'm so glad you asked. I was able to cross out the 12 because 12 over 12 is 1. Do you see how 4 times 3 is 12?
If you divide that by 2, no.
Well, wait, forget the 2 for a minute. Forget the 2. Do you see, Alex, the 12 and the 12?
Yeah, and then you divide the 10 by 2.
And then the 10 divided by 2 is 5. Is everybody 100% on that?
Yep.
And please say no if you do not know. The worst thing in the world is to allow me to continue, because remember, we're not here judging each other. We are here supporting. We are mathematical partners, okay? Now back to this. Back to this.
I get that now.
We now have 495 possible cards. And guess what, guys? Impossible.
How many?
I actually started to do it myself, and I got about 12, maybe 13. And then I actually did a little research. There are 91 impossible cards.
That's a lot.
There are 91 impossibles. Now, before I go back to this, I want to ask you guys a question. Can you guys try to solve this card?
Sure.
Because I thought this one was impossible, and then it came to me. Try to solve that one. Pick up that pencil. And I'm going to give you about a minute or so to think about this one, maybe a little longer. And I'm also going to write out all the combinations of multiplication using my factor method.
4. You can't get 1 from that, can you? You can't get. I figured. No. No, that's wrong. No.
Let me give you a tiny little hint. And the tiny little hint is that this is your solution. 8 times 3 is actually what you're going to be looking for here.
Oh, I have it.
Yeah,
Wait, no.
Raise your hand electronically just so you get used to that. Oh, if you, by the way, Alex, use that pencil. Put that pencil to your paper,
I know. I'm just thinking.
because
right
trust
now.
me, it'll work. Brandon, go for it. Brandon, you raised your hand, right?
No, I didn't.
Oh, okay. I thought you did.
I was scratching my hair.
Oh, no worries, no worries. All right. Would you guys like to see what I came up with?
No.
You don't want to see it yet? You still want to work it?
Yeah.
Okay. I'm going to give you another half a minute because I have a lot more that I want to do with you guys. Ethan, are you working this? Because you look too comfortable, man. I want to see that pencil working.
How many solutions does this one have?
I only found one, and it's either beautiful or ugly depending on how you categorize fractions.
Oh, fraction?
Yep. I kind of went into the non-integer world. I went into the non-integer world. I explored it. And Andreas, oh, you're muted.
Sorry,
Okay, no worries, no worries.
I was talking to my mom.
Oh, yeah, thank you for doing that then. I appreciate it. You're a good man. You're a good man.
How do you turn 2 8s into a 3?
All right, you guys ready?
Yeah.
Guys,
I think I have to know.
what is 8/3?
It's 2.
That's 2.5.
No?
2/3.
I mean, 2 and 2/3.
2/3.
Okay. What is 3 minus 2 and 2/3?
1/3.
1 and 1/3. 1 and 2/3.
What is 8 divided by 1/3?
Oh, 24.
Oh my God, it's time. Oh, yeah.
24 over 1.
It's 24.
Isn't that cool? So, so this is one of the ones that I thought was impossible until I went out of integer mode and I changed my mindset. Okay. Now, if we take the number 495 possibles and we subtract 91, how many actual solutions
404.
are there? Say it again.
404.
All right, 404. So what I want to say to you is this. What percentage are possible? And do not use a calculator. What I want you to do right now is I want you to look at 404 divided by 495. And I don't want you to give me an exact right now. I first want you to give me a really nice little estimate. What percentage of those are possible?
About
But don't say it out loud, please. Don't say it out loud. Send me a chat if you've got it.
Is it a perfect number?
No, it is definitely not.
Wow.
And it's not even, it's not even an exact percentage. It's got to be estimated. So guys, aren't you looking at 400 divided by 500?
Yeah.
Mm-hmm.
And isn't that 4 divided by 5?
Yes.
And isn't that 8 divided by 10?
Oh, is it?
What percentage is that, guys?
80% are possible.
That is 80%. Now, is that why the creators of this game, and I was not the creator of this game,
Oh, I thought you were.
why did the creators of this game choose the number 24? Why would you think they would choose 24 given that 80% of the possible cards are solvable? William.
Because maybe that card has 80%, and that 80% is the highest percent that you can get.
And guess what, William? That's what I thought. That's what I thought. So I did a little investigation and I looked at how many, the percent of possible solutions for, and check this out, the target numbers of 0 through 99. And I thought that 24 would end up being the highest percentage.
Probably not, though.
And now I'm going to disclose to you what I found out. Now I think that Will, by the way, guys, for those of you who don't know, Will and his dad do a lot of JavaScript, or not JavaScript. What is the program you work in, Will?
Python?
Python.
Is it Python?
Yeah.
So I found, and I did not program this, but I found a JavaScript program that solved this problem. And here is what it looks like. I'm going to make this a little, okay. So basically what it did, it was the target numbers between 0 and 99. So for instance, if you have a target number of 0 with 495 possible cards, remember four numbers, right? The digits from 1 to 9.
Oh my
That's
God.
it.
97.
There is 97.8%, close to 98% of the cards are solvable.
2 is like 100 almost.
Yeah, now guys, check this out.
That's
24,
considering their
as we said, is about 80%. Okay, I don't know why it says 397, but it should actually say 404. But in any event, guys, when I did the analysis, it turns out, and let me see if I think I wrote this down. It turns out that 24 is 19th best on the list. Out of 100 numbers, this 80% is in 19th place. So there are 18 other target numbers that would actually have been better. Now, look what happens, guys, when you get into the high numbers. 97, why do you think 97 is so difficult? Who can give me a conjecture on that? Don't say it out loud, please. Who can give me a conjecture as to why 97 is difficult? And I'm going to go with Andreas, Ethan, M, and Will. Go.
I think it's that because it's a very high prime number and
Yeah, same.
You
It's
noticed
prime.
that it was prime, but again, 94 is not prime. Ethan M, what were you going to say?
I was going to say prime 2.
and 94 doesn't have many multiples. And has like this 47 prime number multiple.
And guys, 94 divided by 2 is what?
47.
And do you see how 47 is a prime number?
Yeah.
And I think
that's not
that's
good.
why. So even though 94 is not prime, okay, and then let's look at some other really low ones. Look at 89. Very, very low. Look at 86. 86 divided by 2 is what, guys? Come on.
40.
43. Great. Alex, go.
Prime.
Is it 24 because 24 is the only no, it isn't. Is 43 no, I don't know. I was going to say if you keep on dividing it, it hits the lowest prime number, but.
Now, but the reason why I think, and this is just my conjecture, guys, is that 24, like I want you guys to watch my factor method.
Mhm.
My factor method is always to do 1 and the number itself. And then I double and half. Come on, help me out, guys. Double.
Triple.
No, sorry. That was double and half. Come on, Ethan.
6.
And half. Go. Double, double, double.
8.
8 and
3.
3. So it's got 8 factors. For me, though, I kind of like 48. To me, 48. 1, come on, guys. 1 and 48. Go. 2 and?
And 2 and
24.
24.
Everybody out loud. Ben, go. Come on. 4 and?
16. Wait,
8,
4 and 12.
16.
12.
Six.
And Brandon, you do the next one.
Wait, we missed one, I think.
So Brandon, double the 4, half of the 12. Go.
8.
8, 6.
Excellent. And Kathy, go.
You can just do what we just did.
And 3.
And guys, guess what? This guy has 10 factors versus 8 factors in 24. Now, Ethan G has his hand up. Go, Ethan.
Oh, I didn't lower it. I don't have anything to say.
I'm sorry, I could not hear you, my friend.
I didn't lower my hand.
Oh, okay, okay. Alex?
Oh, sorry, I just noticed that my hand was still up. I had it up earlier because I had another submission today for 8:30.
All right. Now, guys, let's do this. We're going to go to, by the way, I gave you many, many pages. In fact, I think I gave you every single card that comes in the deck. These are all 3-dotters. These are all 2-dotters. These are 1-dotters. Let's go down to this one, and I'm going to grab,
Is the hardest the 3-dot?
oh yeah, 3 dots are the hardest, and I'm
What
now
about
going
the
to
4
take,
dot?
well, I would
The
say the
6.
one that I did with the fractions, I would call that a 4-dotter. Okay, here you go, guys. Get going on this one, please.
5, 7, 9.
Not out loud, though, not out loud. This is such a great game to play any single time, anytime.
Number 6.
And what you guys should do is you should print this out in color on single side, and you should cut them all out. It's really cool to have us. I mean, Ethan M, you did that with our target number, didn't you, last week?
Yeah.
I did it too, by the way.
Oh, we got 15. 2 times 7 minus 9.
Ooh, that's a cool one. I'm going to give you a little push.
Oh.
Also, we're saw.
Oh, and by the way, the underline tells you which way the number goes. So that is not a 6, it is a 9. Remember, guys, pick up your pencil on this one.
35 minus.
Yay! Who just did that? Who just was thinking out loud there? That's so cool. Who got it? Will, was that you?
Yeah.
Will, go for it.
Oh, 35 minus 11.
Not 11. Oh, yes, 11. What am I talking about? Of course, 11. Guys, do you see this? Isn't that awesome? So 5 times 7 is 35, and 9 plus 2 is 11. Subtract them, and you get 24.
Still would have been.
Did anybody come up with a different solution for that? All right, go, guys.
I can't see it. Oh, that one.
Can you see it now?
Yeah.
And I always like to write out the number 24. And remember, you guys should be thinking about all the different combinations. All the different combinations.
Oh, Mr. Kramer, I have one.
Awesome. What can you see?
Oh, I have one.
Mr. Kramer, can I say mine?
You can say yours and then Ethan M. Go.
Okay.
I think he has the same one
5
as me.
squared
5 squared.
Ooh.
Not the same.
minus 4 divided by 4. The quantity of 4 divided by 4.
But there aren't.
Wow. Wow. That is awesome. And
I
remember
did
how,
different.
do you remember how Alex used 5 squared earlier? So that really, I think that was really helpful. And do you have a different one, Ethan M?
Yeah. 2 to the 5th minus 4 plus 4. Quantity of 4 plus 4.
God. 2 to the 5th, which is what?
32.
Minus.
The quantity of 4 plus 4.
Wow. And Will?
5. Wait. So 4 plus 4 times 5 minus 2.
4 plus 4. Say it again.
Times 5 minus 2.
Yeah, guys, I think, believe it or not, I think this one, that's the one that I saw immediately because it was like those numbers we've been working with, right? Those factors. These solutions take a lot more effort. So William focused on simplicity. Ethan and Andreas, you guys, that was a little bit more elegant, but frankly, they're all just as good. Let's do one more.
Possible to have a 4 dot.
Wait, do you guys think there's another one?
Maybe.
Well, it's the end of class, so you're probably going to show us another one.
All right, you guys are getting hungry, huh?
Mm-hmm.
All right, so let me throw out one more.
Hungarian.
One more. And screen capture. There we go. And we'll do 3188. 3188.
Oh.
I have
And guys, I think it's a little
Wait,
cheap.
wait.
I think it's a little cheap, by the way, to do this one. I'm going to say that this one is a little bit too cheap.
Oh.
1 to
Yeah,
the
then times 8 times 3.
So do you see what I did there? I basically
Yeah,
eliminated.
can we do another one? That was a bit too.
no.
Yeah,
we
but
have
no,
to
but
try
we're not gonna. I'm gonna say that this is not a solution that I want you to go for. I want you to stay away from these because they're a little bit too easy. But I want you to find a different one here.
Why are you freaking out?
Oh, I have it. Oh, wait, I raised my hand.
That's okay, buddy. Raise your hand electronically. William, and then Alex.
No, I forgot to lower it. I don't have anything.
Oh, you don't. Okay, and so Alex, give us your idea.
3 minus 1 is 2.
Wait, louder, please.
3 minus 1 is 2.
Good.
Times 8 is 16. Plus 8 is 24.
Wow. That is elegant. That is beautiful. Any others, guys?
Yeah.
So let's see. Huh. Kind of cool, guys. Kind of cool. So, by the way, I wanted to just show you one other thing. This is something I did for my other students, and you guys can do this as well.
Oh, wait, I had one.
Okay, hold on a second, Ethan.
Oh,
What I want you guys to do is create your own game cards. So if you come up with the pattern like 1 times 24, you could then make a game card that gets to your solution. And that's in your packet as well. And Ethan M, I have to find where we did this, Ethan. So just give me a half a second.
I just thought of one.
All right, and hold on. Go.
8 plus 1, that's 9, divided by, 8 plus 1, the quantity, divided is divided by 3, 9 divided by 3 is 3, and then 3 times 8 is 20.
Wait a minute. Yes, 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 that is beautiful. Wow. Guys, that was awesome. I'm so proud of you guys. And we learned some pretty hefty rules today, okay? And I just want to just note that the NCR, which remember is n factorial divided by n minus r factorial times r factorial, is a great way for you guys to think about combinations. And we're going to be doing a lot more with combinations and also permutations. And this is where order matters, where the number 2758 and 2857 would be considered two different ones. But clearly in the game 24, we're in the world of combinations.
Is permutation where you just take it?
Louder, Ethan, please.
Is permutations where you just insert like functions there?
You have to go louder for me because I just can't hear you, buddy.
Do you put functions in between the numbers for permutations?
No, permutations NPR is n factorial divided by n minus r factorial. And we will go over that in a future lesson. You were amazing, guys, as always. I love this class. I will see you literally in 167 hours. Say goodbye to your friends. And say hello and goodbye to Alex, who you've seen for the first time and who's like one of my really, really fine students from many years ago. And Ben, who joined us, which is awesome.
Good.
And Brandon, who is new to this group. So everybody, you are amazing. And Kathy, good night. Good night,
Bye.
guys.
Bye.
Take care.
Bye.
Great to see ya.
Bye.
Have fun playing the game.